How do we find rare stars that are hidden among a background of ordinary stars? Today is day 22 of learning computational astrophysics, and I looked into classification. Unlike regression where we predict a continuous value, classification predicts a discrete class. Generative classification builds a model of how the data can be generated by each class. When we observe a new object, we see how well it fits each model, and then we use Bayes' theorem to decide which class it most likely came from. I looked at this using R.R. Lyry's stars, using the colours as its features. I compared completeness, which is how many real ones we actually recover, against contamination, which is how many of the selected objects are actually wrong. I started with Gaussian naive Bayes. Each feature is modelled with a one-dimensional Gaussian, and we make the naive assumption that they're conditionally independent. This recovered about 88% of the R.R. Rayleigh, with about 79% contamination. But features in real data can be related, so we relax that assumption and include correlations between data. One way of doing this is LDA, where we assume identical covariances between the classes. This makes the quadratic terms cancel, leaving a linear decision boundary. This gave around 67% completeness and 81% contamination. We can relax that assumption too, so that each class can have its own covariance, which leaves the quadratic terms and allows the decision boundary to curve. This is known as QDA. This improved to around 79% completeness and 67% contamination. But even QDA describes each class still using one Gaussian. Gaussian mixture Bayes instead uses several Gaussian components for each class, allowing more complicated distributions. Using 3 components, contamination dropped to a whopping 24%, while completeness stayed at 69%. However, Gaussian mixtures still use a limited number of components, so we can extend this to kernel discriminant analysis, where we place a kernel at each training point. We then make this local region depend on nearby data, allowing us to use nearest neighbor algorithms. Using a k nearest neighbor classifier simplifies the k nearest label points, allows them to vote, and assigns a majority class. With 10 nearest neighbors, it gave around 53% completeness and 24% contamination. But that's everything. I'm just gonna go code right now. That was day 22. See you next time.